Good. Today I discuss the sampling technique. Okay, we are already know what is sampling. Sampling is a technique which convert the continuous time signal into discrete time signal. So how we convert the continuous time signal into discrete time signal? There are three types of sampling technique. There are three types of sampling technique. Okay, there are three types of sampling technique. First is instantaneous sampling. Instantaneous sampling. Okay, instantaneous sampling. Second is natural sampling. Natural sampling. And third is flat top sampling. There are three sampling technique. By the use of sampling technique, we convert the continuous time signal into discrete time signal. The techniques of sampling are instantaneous sampling, natural sampling, and flat top sampling. First, we consider the instantaneous sampling. Okay, first we consider the instantaneous sampling. The instantaneous sampling is also called ideal sampling. Ideal sampling, or it also called impulse sampling. Okay, the instantaneous sampling is also called ideal sampling or impulse sampling. Okay, in this type of sampling, the sampling function is train of impulses. So here the impulse pulse is used. So it is called the impulse sampling. Okay, impulse pulse is used. The sampling function is a train of impulse pulses. Train of impulse pulses means it's considered it looks like a impulse pulses, means this type of pulses is called the impulse pulses. Okay, this type of pulses is called the impulse pulses. This is called the train of impulse pulses. Okay, this is called the train of impulse pulses. Impulse pulses is denoted by del Ts. Okay, impulse pulses is denoted by del Ts. It is the function, it is the time domain, so it is called T. So impulse pulses is denoted by del Ts in time domain, so it is denoted by T. Okay, and this is the 0. This is the 0. Okay, time pulse is 0. This is the Ts. This is the 2 Ts. This is the 3 Ts. This is the 4 Ts. This is the 5 Ts. Okay, and this is the minus of Ts. This is the minus 2 Ts. This is the minus 3 Ts, and so on. It is called the impulse pulse. Impulse pulse. Okay, it is called the impulse signal or impulse pulse. It is also called a impulse signal, just like a sine wave. Okay, it also called a impulse signal. Okay, and the circuit which produce ideal sampling is called switching sampler. Okay, the circuit which produce ideal sampling or instantaneous sampling or impulse sampling, okay, is called switching sampler. Okay, so the circuit which produce the ideal sampling pulses, okay, the circuit which produce the ideal sampling pulses is called the switching sampler. By the use of switching sampling or by the use of switching sampler, the instantaneous sampling technique is used, or instantaneous sampling technique is produced by the use of switching sampler. Okay, the working function or working principle of switching sampler is depends on principle of multiplication, okay, the working principle of switching sampler is depends on principle of multiplication. Okay, so here two signal is multiplied and the output signal is instantaneous sampling or impulse sampling. Okay, so the switching sampler circuit is called the switching sampler circuit. Okay, this is called the switching sampler circuit. Okay, this is the switching sampler circuit. This is called the XT signal, means message signal, okay, or baseband signal. Okay, and this is the switching. This is the FS. Okay, impulse signal. This is the ground level and the output is GT. The output is GT. GT is the instantaneous sampling. Okay, or GT is the sampled signal. This is a switching sampler. This is the circuit of switching sampler. Okay, so this is the XT. XT is a baseband signal. Okay, XT is a baseband signal. So we discuss how baseband signal or how continuous time signal converted into sample signal or discrete time signal. Okay, by the use of switching sampler. So this is the baseband signal. Okay, this is the baseband signal which is denoted by XT, which is denoted by XT. Here T and this is the XT. It's called the baseband signal. Baseband signal. It is called the baseband signal. Okay. So baseband signal is multiplied by the impulse train of impulse pulses. Means this is this pulses. Okay. Okay. This is the train of impulse pulses or impulse train. Impulse train. Okay. It is denoted by del TS and function of T. XT means baseband signal and it is the time domain signal, so it is denoted by T. Here also a time domain signal, so it is denoted by T. So this signal and this signal is multiplied together. Okay, so the output signal is sampled signal, which is this signal is called the sample signal. Okay, it looks like a baseband signal. this is the baseband signal. Okay, so it is looks like a baseband signal, and we consider this is the GT, because the output is GT, the output is GT, which is called the sampled signal. So this is the GT. Okay, so this is the 0. Okay, and this is the TS. Okay, this is the 2TS. Okay, and so on and so on. Here also minus TS, here also minus 2TS, and so on. This is the minus TS, minus 2TS, and so on. And here also this type of signal is called the sampled signal. So this is considered a sampled signal. Sampled signal. Okay, so this is the baseband signal and this is the impulse trail. These two signal is multiplied and convert this sample signal. Okay, so two signal are multiplied, then get the output signal, which is a sample signal. Okay, this is called the sample signal, and this sampling technique is called the ideal sampling or instantaneous sampling or impulse sampling. Okay, but here we consider the output GT. GT is called the sampling signal, which is the output of GT. This is the GT, and we consider the output ZT, the pulse, the width of the ZT, the width of ZT. Okay, the width of ZT is denoted by tau. The width means this is the width of the pulses, and this is the width of the pulses. Here the no width of the pulses, so the width of the pulses is 0. Okay, from the output we get the width of the GT is denoted by tau, means tau is denoted the width of the pulses is 0. And second is, if width is 0, if width is 0, the energy of the signal, okay, is very low, is very low. Okay, very low. If width is 0, width of the signal is 0, so the energy of the signal is very low. If width is high, the energy of the signal is high. Here the width is 0, so the energy of the signal is very low. So noise interface is high. So noise interface is high, means the noise is present in this sample because the energy is very low. Okay, and third is ideal sampling. Ideal sampling is possible only in theoretical, only in theory, because it is impossible to have a pulse train whose width is 0. Okay, so this sampling technique is possible only theory, because it is impossible to have a pulses whose width is 0. There are, every pulse has some width, but the width is not 0. Width is 0 is not possible. Width is 0 is not possible. So this sampling technique is possible for theoretical. In practical, it is not used. It is not used because the width of the pulse is not 0. Okay, so the circuit of switching sampler which produce the instantaneous sampling, here the circuit consists of a switch. This is the switch function. Okay, this is considered as a switch. We assume that the closing time of the switch approach to 0. The closing time means here the t is approach to 0. Closing time is approach to 0. Then the output gt continuous only instantaneous value of input signal xt. gt is continuous only the instantaneous value of input signal xt. Hence the width of the pulse is 0 because the time closing time is 0, so the width of the pulse is 0. Okay, here the switching time or closing time is considered as 0. So the width of the pulse, the output sample signal, means this signal width of the pulse is 0. Okay, so thank you.